This quadratic equation in d by dx. We see here this d by dx and this d by dx whole square. This quadratic equation. This is a quadratic equation. Quadratic equation in d by dx. Okay, this is quadratic equation d by dx. So we have to find out the two values of this. Therefore, the values of two values of d by dx. For that, what we do therefore the two values, let me write here. Two values of d by dx will be, what will be those values? We know that b square minus 4ac. Okay, if b square minus 4ac here, what is b square minus 4ac is greater than 0, equal to 0, or less than 0. There are three conditions here. What is b here? B is this middle term, coefficient of d by dx. This is the b here. Here b is equal to, let me write, okay, here b equal to, this is step, twice del square f upon del x del y. What is a here? The coefficient of this d by dx whole square, this one. This is del square f upon del y square. And what is c here? C here is this last one, del square f upon del x square. So what is b square minus 4ac represent? Now let me write what is b square minus 4ac. So this equation, I mean this one, c is this one. This is b here. A is this del square f upon del x del y square. Del square f upon del y square is a coefficient of this is square value d by dx whole square. Coefficient of this is this d by dx coefficient is this b, okay, and this is c. This is x square plus bx plus c, the equation. Okay, that's quadratic equation. From that quadratic equation, if we compare these two, these can be written in this way: b square minus 4ac. That means this is quadratic equation in d by dx. So let me write that with the condition then. So b square means this whole square. That means 4 del square f upon del x del y whole square. Okay, is minus sign 4 into a into c. A is here this del square f upon del y square into c del square f upon del x square must be greater than 0 for distinct. This is for distinct tangents. Tangents are distinct, then it must be greater than 0 or equal to 0 if coincident tangents are coincidents. Okay, if tangents are coincident, then this must be equal to 0 and less than 0. So for, let me write here, for distinct, for tangent to be distinct, let me write here, for tangents to be distinct, for tangents to be distinct, what I'm writing here, for tangent to be distinct, coincident, okay, or imaginary, non-real, or imaginary. Okay. So when coincident points are there, then it will represent cusp. This is when distinct are there, then node, and imaginary in case of this conjugate points or isolated point. But the isolated point that I didn't define, but I'll define that. What is the isolated points? Okay, so this is imaginary. For imaginary, it must be less than 0. Okay, this value must be the difference b square minus 4ac must be equal to less than 0. If the difference of this comes out to be negative, then the tangents are imaginary, not existing. Okay, that is conjugate point will be there or isolated point will be there. If it is less than or equal to 0, then tangents are coincidental, they are same. So cusp will be there. If it is greater than 0, I mean the difference of these two, each one has 4ac, comes out to be positive greater than 0. That means there are two distinct values, okay, of this. So there are two distinct tangents, sorry, node will be there. In this way, we have to find out. So if I solve this, or this value, del square f upon del x del y, if I divide by 4, okay, so minus this is del square f upon del y square into del square f upon del x square. Okay, if it is equal to or is greater than 0, is positive, divided by 4, no problem. Then the two tangents are distinct. Tangents are distinct. Then tangents are distinct. Okay, and if it is equal to 0, this is equal to this, or sorry, whole square of this. I'm sorry, whole square of this, or del square f upon del x del y whole square is equal to this del square f upon del x square into del square f upon del y square. If they are equal, then tangents are coincident. Then tangents are coincident or coincident. Tangents are coincident. So this is condition for coincident. If these two values are equal, and if their difference is less than 0 means negative, that means no tangents are there. But if all these three are zeros, or let me write here, if del square f upon del x del y equal to 0 equal to del square f upon del x square equal to del square f upon del y square, then there will be no tangents. Then there will be no tangents in this case. No tangents. Tangents will not exist. Okay, that means there is imaginary points, we may say, or conjugate points are there, but tangents are not there. Really, tangents are not present. This is our condition is this. Now let me talk about these questions. So how to find out double points or tangents upon the origin? Let me define that questions. So these are the basic definitions. What is the isolated point? Let me, one point, double point we defined, then conjugate point or isolated point, let me talk about. This definition is also left over. And the C part, we talked about node, cusp, and this is isolated point. Isolated points or conjugate point. Or conjugate points. What is the isolated points or conjugate points? Let me define this. If there is a curve like this and another point is P, now in the neighborhood of P there is no any tangents or curve. This curve is very far away from this, there are no tangents here. If in the neighborhood of P points, in the neighborhood of point P, there are no tangents here nearby. Neighborhood of P, there are not any curves or tangents upon the curves or tangents upon the curves. I mean tangents are not real here. Tangents upon the points, I'm sorry. No tangents upon the points. Double points, I mean. Points or tangents are not real. Or tangents are not real. Or tangents are imaginary. or tangents are not real. Okay, nearby P. There are no tangents here. So in this way, this point is an isolated point or conjugate point. Conjugate points, this one is conjugate point or isolated point. So this the third type. We have talked about node, cusp, and this is isolated point. There are three varieties of double points here. Okay, so this third point, conjugate point, whenever the value will be negative, okay, of dy dx, or just we solve that equation. If we are finding out tangents, suppose, and the tangents are finding out, in that solution, if the points are given to us, and if the solution of the points is not possible, then we say, or is not satisfied, I mean, if the two values find out of the points and those points are substituted in the given equation of the curve, and that curve is not satisfied, that equation is not satisfied with the curve, then we say that there are no tangents, tangents are imaginary. We can say that that isolated point is there or conjugate points are there. Okay, so this is what we call imaginary points or conjugate points in this case. So conjugate points or isolated points. This is isolated points or conjugate points. Let me now take these questions one by one. Okay, so what are these questions here? One by one. Let me talk about them. First of all, we have talked about cusp, nodes, variety of cusp, okay, double points, tangents, how to find out tangents upon this. That let me define this is 8th question here. I'm sorry. Okay, so now let me take first question. Find the tangents at the origin and double points of the curve dash. So let me find out the tangents here. Question number 1 for the process will define this. Let me take this. So question number 1 here. It says find the tangents at the origin and double points of the curve. So how to find out tangents upon the origin? That is, they say that constant terms if are not there, or there is no single order, or sorry, single degree terms which must not be there, we have not to equal to them to 0, because then we cannot find out 2 points. So at least second degree term must be there. So we have to just equate the smallest degree term to 0. We have curve given to us. Let me write here curve. Put the curve given here. The curve, equation of the curve here is for the curve equation of the curve here, y square into twice a minus x equal to x cube. This is first equation. This is the equation of the curve here. Okay, so the curve here is, or equation of the curve here. This is equation of the curve. Here is this. Okay, just to find out tangents, what we do? So to find out the tangents, we equate the lowest degree term to 0. What do we get here? Here, this is the lowest degree term, because y square into twice a, lowest degree because y square into x, there are two variables, so 3 power will be there, this is 3 power. Lowest term is only y square equal to 0. So this implies that y square equal to 0, or we get here y equal to 0 and y equal to 0, so 2 points are there. Here, the two double points is there, but that double point, in this case, tangents are either, let me write here, so the tangents okay represent here are real, but there may be a because it says 0 here, are real, but the double point, there may be a double point which is maybe cusp, but the double point this double point here may be a cusp or a conjugate, may be a cusp, but these 2 points are not different, so it's not a node, it's a cusp here, or maybe a cusp or a conjugate point or a conjugate point or a conjugate. That we have to verify here. Now if I solve this equation for y here, let me talk about that. So rewriting this equation in this way. So rewriting the above equation, let me write here. Rewriting the above equation as y square is equal to x cube upon twice a minus x here, or y is equal to, let me write here, or y is equal to x to the power 3/2 divided by square root twice a minus x. Now in this case, if x is positive and near to the origin, very small value, if x, the value of x is positive here, x is positive here, positive, and its value is near to origin, that means value is very small. Value of x will be small here, but if it is positive, then near to origin, then y will be positive here. Okay, then y will be positive. Sorry, this is plus minus, I'm sorry. Then value of y will be positive and negative, both positive and negative. The value of y are positive and negative, that means there are two different values here. So this will give us two distinct values of y. For two distinct values of y, x will be one value. So there will be 2 points there. That means the node is there. Okay, so this is positive point. But if x is negative, okay, if x is negative, then its value is imaginary, because this x cannot be, the square root cannot be calculated of this. But if, let me write here, if x is negative, then y is imaginary. Then y is imaginary here because it's plus minus. Then y is imaginary. Okay, imaginary means we cannot calculate that, or in real terms, non-real value, it will be imaginary or non-real value, or non-real value. Okay, so in that way, if it is non-real, then it will be conjugate point, the value. But if x is positive, then there are two different values, so there will be a node here. Okay, that cusp will be a node type of, because there are two different points. So the two different points, one positive and negative from this one, may lie upon this type. Okay, so this cusp may be of different kind. This y is negative positive, so this x here is the tangent line. So this can be like this curve, it may be. This is a cusp of first species. First species of not node, but first species of first species, cusp of first species. Okay, so it may be a cusp of first species. Then it will be or it will represent a cusp. It will be a cusp of first species, or first species with axis of x as the tangent, with y equal to 0, with y equal to 0 as the tangent, equation of the tangent, as the equation of tangent. Let me write here, equation of tangent. So y equal to 0 means axis of x. This is axis of x. Y dash, this is x dash, this is origin. This x on the x-axis, y equal to 0 is the equation of the tangent in this case. But value of y positive above and negative in the below. So at the value of x, some positive value of x, y are two values because positive negative values were there. It means this is cusp of the first species, okay, having y equal to 0 as the tangent. This is the first equation, first question I mean. Question number 1 is done. So in this way, you have to solve that or find out that what is the find the tangents. So equation of tangent is this y equal to 0 at the origin and passing through the origin, okay, and double points of the curve. Points are double point y0, 2 points, x may be positive. If we take positive, then combinations are there. Double points may be, number of points are possible. Okay, so those double points be 0, 0, x is 0 sometimes if we are taking positive, then it is, 0, y is 0 then. Okay, then if y is 0, x can be positive value also. Okay, if y is negative, then x is positive value, some positive because 2a minus x is by there, 2a minus x by there. If x is positive, then it will depend upon 2a. If x is less than 2a, then positive value. This is there. Okay, so but it's positive. So the square root of positive value will be positive. That means some real values will be there, positive, negative. In this kind of cusp will be there. So first species type cusp, but equation of tangent is this y equal to 0. So question number first we have done. Now let me talk about second question. What does question number second say? Let me talk about. So question number second in this case is what? It says it should show that the curve this has a cusp at the origin. So we have to prove this that this is a cusp. Question number second here. So the equation of the curve here, equation of the curve here is, what is the equation? This is x cube plus x square by equal to a by square. Okay, a by square here has a cusp. It says this is equation number 1. We have to prove that it has a cusp here. But the curve this has a cusp of at the origin. What is the equation of the? So to find, let me solve it. Solution. The solution here. So to find the equation of the tangent, we have to equate the smallest degree equation this. So to find the tangents, okay, upon a curve or of a curve, we have to equate the smallest degree term to 0. We have to equate the smallest degree or a smaller degree term, the smallest degree term or terms to 0. But here, no, this is the second kind. This is only this one is the smallest one. This a by square equal to 0 or y is equal to 0. So y square equal to 0. This will give us y equal to 0, y equal to 0. 2 points are here. So it will give us cusp. Then it will be a cusp. Let me solve this equation for y here. For the equation of the y, let me solve it for y. Now this is a quadratic equation in terms of y square into y. This x square, we can write it as a y square minus x square by minus x cube equal to 0. Rewriting this equation. This is rewriting the equation. in this way. A y square, this is the quadratic equation in y, so y is equal to, okay, this is minus b, that means x square plus minus under root b square. B square means x square means 4, x4 minus 4a into c. This plus sign, so it will be plus sign here, 4a into x cube. 4 into a into x. This is positive. B square minus 4b square. This is minus x whole square. There is a positive value. Minus plus here, so 4ac. 4a is here a, x square. Now, upon 2 into a, on 2 into a here is there. Okay, now in this case, for positive value of x here. Okay, so in this case, this is positive value. It will depend upon this value. So here x square, it is positive, negative. Okay, let me take a by square. Both are negative here. Okay, no problem. 0. This equation is given to us as x cube plus x square y. Okay, no problem. This is the equation here. Now from this equation, for positive values of x, small value of x here, we can get here positive, negative value, because this is plus sign. If you roll, this will give us positive sign. If it is negative, then it is negative value, is positive. It will depend upon this, it will be negative value. Okay, let me take first positive value. For positive values of x, for positive value of x, for positive value of x here, the value of y will be positive, negative, because this is positive, this curve is positive here, so real value. So value of y will be negative and positive, both positive plus or minus. So value of y, values of y will be negative and positive, both negative and positive. If it is negative value, it is negative here. Okay, so in that situation, this value will be imaginary. But in this case, it is representing a cusp. Because y equal to 0, 0, it may be a cusp or a conjugate point. At y equal to 0, 0, y equal to 0, we prove this y equal to 0. It may be a cusp or a conjugate point. So it may be a cusp or a conjugate point. If there are two distinct points from here, so we see for positive values of x which are near to smaller value of x, which are near to origin, that means smaller value. This will be positive in that positive values. This will represent here positive and negative. That means two values of y are there. Again, there will be a cusp here. So it will represent a cusp, negative and positive. So it will represent a cusp. With positive, negative value of y, the x-axis. X may be positive, negative, whatever values are there. So we cannot say that x is negative, positive value. So x may be any number here, but a value of y are positive and negative both. Because if it is plus sign, negative, then difference of this will be a smaller value. They cannot be similar values. Different values are there. So we cannot say that x-axis is the tangent line. Okay. It will represent a positive, negative. So it will represent a cusp in the first and third quadrant. First and fourth quadrant. In the first and fourth quadrant. Try to understand. Into first and fourth quadrant. Because x are, or y values are positive and negative. It will be similar type. The cusp is like this here. It may be here, here, or it may be from this side. Okay, this is the tangent line, this is the tangent, because x is positive, negative, x now, y is positive, greater value, negative, some y points is here, x is here, so that point may be there. So x can start from here also. If we take x value, some negative, positive value, or y is something different, it may be that kind of curve. Okay, this is there. So this kind of, okay, cusp is there. So it will represent a cusp here. Y equal to 0, 0, it means it may be a conjugate point or a cusp, not node point. There are double points here. I mean, value of y are 2, 0, 0. So that value of y means axis of x is there. Axis of x in this case may be one of the cusp here, cusp having tangent line here, that y equal to 0. So y equal to 0 is the equation of tangent again. So it's a cusp. It will represent a cusp here. Hence, it will represent a cusp. It will represent a cusp with y equal to 0 as the equation of the tangent line. Again, so this is second question we have done. Now let us talk about third question. What does question number 3 say? Let me check it. Show that the origin is a conjugate point on the curve of this. Now let me talk about this question. Question number 3. Equation of the curve given here is equation of the curve here is the equation here x4 minus ax square y plus ax y square plus a square y square plus a square y square. Okay. Again, if I take this as quadratic equation in y, it is equal to 0. So these two terms are equal to 0. Sorry, this again a square by this term is equal to 0. Here again is a solution. Solution here. Here again, to obtain the tangents, equating the smallest degree term to 0, equating the smallest degree term to 0,